Yeah, hi, I'm Roland. I'm a front-end developer, front-end engineer in New York City, and I got into WebVR because it's for me, my idea is the next level of responsive web design. Who of you guys has any experience with VR, has used VR headsets before? One, two? Yeah, just has used a Vive, a Google Cardboard device, anything? Okay. Who has an idea about JavaScript here? A little bit? Who would say they're good with HTML and CSS? Okay, half of the room. And who does have no coding experience whatsoever? Okay, that's fair enough, because I hope I make it easy enough. Good. Yeah, let's talk about WebVR. But before I want to define a few things. There's two different kinds of WebVR VR experience at the moment. We have the setup of the WebVR headset, where you have a dedicated device that is powered by an engine, by a computer, by a game controller, and then you have the mobile-based VR experience. So the difference of that is not only performance and quality right now, but it's interesting how we can actually see that these two worlds can coexist, and it's going to be a very exciting time. When we create WebVR experiences, a lot of us already created apps, maybe, like web applications, websites. There's a whole different set of user experience variables that we have to learn about when we create VR. Not only you're using a device that is completely new, it's not a mobile phone or a computer, it's actually you immerse the person into a space. So there's a whole different kind of level of understanding of user experience that you have to account for. Here are a few examples of variables that are important, and I split it in two parts of the user experience and user comfort. More than ever, if you create a VR experience, user comfort becomes more important, because you want to have people to feel comfortable in the environment you create, and you have to also pay attention to the fact that if the user doesn't like it, he won't pick it up again, and you want to make VR a mainstream kind of platform. So here are a few things that I have to do with the VR experience. Once you have the stereoscopic vision, obviously the 3D effect, we had like red-blue filters on TVs, but in VR it's actually on both eyes, a split screen on the phone or in the headset. Then the field of vision, of what is your peripheral vision and how far does your view outside of your actual focal line extend in the headset. It all depends on lenses, on screens. There's all different kind of variables in that. And then we have the difference between 3 degrees of freedom and 6 degrees of freedom. Who knows what degrees of freedom is in this room? A little bit. So we're talking about angles. So a phone, like a mobile phone, has an accelerometer and a compass basically built in. So we have the turning on the 3 axes, X, Y, and Z. That's 3 degrees of freedom. But if you have a tracking device outside of your headset that tracks your actual position, X, Y, and Z position in the room, then you have 3 additional values, so it's 6 degrees of freedom. So that's the difference between the room scale VR experience, where you actually can move within the room, and the 3 degrees of freedom you have on a mobile headset, where you're actually just centered in the space, and it doesn't recognize if you're going down sit down on a chair or lay down. It just gives you one perspective, one height. Just quickly going over the devices out there right now and actually coming out soon. We have the obvious HTC Vive, which is actually the only device that has the real room scale VR experience, the real deal. If anyone of you has the chance to go to the Tribeca Film Festival in New York City, there's the VR arcades there. There's a lot of HTC Vives. and things to test and interesting little projects. I was very excited to see that stuff. Then we have the Oculus Rift. Oculus Rift has still problems with room scale VR, but has 6 degrees of freedom because there's a tracker. There's like a sensor outside of the headset that tracks the motions of the head. Then you have the PlayStation and the Vive, which actually is eye tracking, which is also very interesting because you can actually track the movement of the eye within the headset. And then you have OSVR, which is an open source VR headset, which is basically like a screen inside of a headset, also 3 degrees of freedom, not 6. Then the next step is obviously the mobile VR. Then you have the Samsung Gear VR and the Daydream, which is mobile VR with an additional feature, which is a clicker, better hardware tracking, and down the line to the cardboard device, and also the hundreds of third-party headsets you can find on Amazon with different kinds of levels of quality and fabrication, but always around the idea of actually housing your phone and making this experience comfortable on your face. Down to the Homey Duo mini player, which is just a clip-on, just so you can walk around with it. Pretty easy little thing. So when we talk about VR programming, we have those big programming engines. I know today we're going to hear more about Unity. The point is, most of those software development platforms are C# and C++. But with WebVR, we're introducing JavaScript into the mix, which is for all the web developers big release, because we can actually use things that we know to create something fantastic, just like we could with Unity. Plus, you have the distribution channels. If you create applications for the HTC Vive, Oculus Rift, even Daydream, you have to go through distribution channels like SteamVR and the Rift stores. But with WebVR, you do not have that ecosystem. You can actually distribute directly via link. You don't have any kind of platform that can say that you can not publish something. You directly can share experiences, test experiences, all different kind of levels, and be available to the 3 billion internet users out there. And yeah, so like I said, you can use libraries that you're used to, like JavaScript, HTML, depending on what framework you're using. And you can switch between a VR mode and non-VR mode, which is very interesting if you want to make some kind of progressive enhanced experience from an application that should work on a desktop or then also work on a headset. I found a nice animation from Arturo about the idea of the progressive enhanced VR experience here. So we can have the desktop, the touch screen, the mobile phone, and then the VR headset, and then the higher level VR headset, which is the Daydream device in this case. Right? Good. Let's have a look at the history of the actual virtuality on the web. Just a very quick retrospective. It's not a new thing. WebVR has a history which goes back to 1994. VRML, some of you might know about VRML still. It was the first start to describe 3D content on the internet, which was a great concept, spearheaded by Tony Parisi and Mark Pesce and Peter Kennard. They created a labyrinth demo for like walking through a labyrinth on a browser. That was Netscape at that time. The problem with that was it's all plugin related. It's just like Flash, you need to install and plug into Experience, something that wasn't standardized. And over time, we also got WebGL, which is the Web Graphic Language API, to access directly the graphics processor from the browser. So we don't have to, so for performance reasons, your device could actually directly access, the browser directly accesses your 3D engine. and that also paved the road for a standardization of WebGL, and then there was VRML turned into X3D, and nowadays still X3DOM is going on, so there's a link there. I'm sharing all this on my GitHub, and I'm going to give you the link so you can actually go through this presentation and click all the things and dive deeper. So WebGL is one of the strong, is now a standard across the board on all browsers. And there's a lot of popular engines that tap into the WebGL library. One of the biggest engines is 3JS, which is made by Ricardo Cabello, or Mr. Doob, like we know on his GitHub. Then there's Babylon.js and the others. All those are JavaScript libraries that can build 3D environments for games and are basically the base for a VR environment, because you need to describe something in 3D to walk through it. I made a quick search on Stack Overflow about how popular those JavaScript libraries are, and we clearly see that 3JS is a winner, and that's not surprising right now. But that's why we're going to continue and look at that. So WebVR is next to WebGL, another API that's it's going to be supported on all browsers. Right now it's not. It's still in experimental mode. Microsoft Edge actually a few weeks ago established it as standard in their actual browser right now, which is the first one. Chromium. And from Chrome and Firefox Nightly, the experimental browsers supporting WebVR 1.1. But they're developing right now WebVR 2.0, which is not backwards compatible. So a lot of things that are defined WebVR 1.1 is going to be obsolete. So it's still growing a very unclear territory, but it's still definitely something you need to look into. And the idea of WebVR, the next level was a big process, and there's this explainer document that I'm linking here, which explains the perspective of what WebVR as API is supposed to do for the developer, what is the task, and I summarized it here real quick. It's about the browser understanding what kind of device you're using. So if you're using a Samsung Gear VR or the Google Dream, yeah, you know. Then it will understand that you have a pointer or you have an external hardware accelerator and stuff like that. Also, it understands what the resolution of your screen is and can lower the resolution to increase performance and frame rate. That's the goal of WebVR. What's not the goal of WebVR is to define the new way how to browse the internet. And it's not supposed to create the metaverse. Basically, that's all on you. It's you who create these experiences. WebVR is just a tool to make the technology work for you and understand what you're working with. We have a few WebVR frameworks that have to be pointed out. On the very top is A-Frame, which is what I'm going to teach you in the second part of this presentation, a little workshop about that. React VR, which just came out officially from Facebook. They're building the React JavaScript library and build these modular elements in VR, which is very interesting to look at. There's Forge.js, which is more like a 360 experience, so you can slide through experiences in 360 photography and videography, and some social development applications like Visor and Janus, which is a browser example for WebVR. So you can access all those links also again on my GitHub. And now I'm going to ask you a quick question, if you can tell me the difference between 1 and 2. 1 second. I want to tell me, okay, so this is one. I'm going to scale it down. And this is one, just because, so. Okay, so that's me in the office. Can anyone tell me the difference between the two? Anyone? Yes? Okay, yeah. The field of vision has changed, but the big difference, I mean, it's not a really good photo, but what I want to point out is just this thing. You know this one? So you're saying this one on the right is a better quality, maybe, but from the code, it's what it does is basically the same. Well, the big difference here is this on the left is 3JS with WebGL, and on the right is A-frame. And now I'm going to show you what the difference between these two examples is. This. On the left, you have 3JS and WebVR, which is 184 lines of code. On the right, you have A-frame, which is exactly the same thing, with 22 lines of code. Okay? So what we're seeing here is that building 3JS and WebVR is a job of someone that really knows JavaScript. You have to load libraries, you have to define elements from scratch. What we have with A-frame is a very semantic, logical way how to describe an environment, taking a lot of assumptions already, and it's much more readable and much more digestible. Yes? I built the left side using a sphere with the same photo, with the same animations timing. On the right, I described it with using the library. So effectively, it was doing the same thing. The difference, obviously, is the little icon on the right, bottom right, which is switched to VR mode. But that is something that's being generated by A-frame. That is the idea of the progressive enhancement. We're right now on the desktop. If you would be on the phone, you could press that button and you would have a split screen with distortion. So let's talk about A-frame, because it's so nice and simple. Let's look at that. So A-frame is a 3D ML, it's a 3D markup language. Just like 3x DOM, X3 DOM, which is based on VRML. It's based on an entity component system, which is basically what the same principle is being used in all the other software, 3D softwares like Unity and Unreal Engine. The stack, what is A-frame using? You see here you have the DOM, which is the HTML and the JavaScript file. And then you have A-frame as library. And A-frame uses 3JS to manipulate the DOM and describe elements and using the APIs of WebVR and WebGL. And if you have a browser that does not support WebVR yet, which is most of the browsers out there, it uses the WebVR polyfill to basically create a visual layer that accepts WebVR. So you can use your A-frame on an iPhone, on Safari, even though it's not even considering WebVR at this point. What is an entity component system? Just quickly for everyone to understand the dynamic behind that. You have the element, the entity, the object, and you have a set of components you can attach to that object. Now every entity has its standard components to it, like position, rotation, and geometry. Otherwise, it wouldn't be able to be described as a visual element in the VR environment. But you can add custom elements, so you can create custom components to add to this entity. So you could add gravity to it. You can add light, textures, shaders. all the different kinds of stuff to that, how it behaves. So you can build an economy around components that are reusable, and you can add them to different kind of entities. From a structure, A-frame is very similar to HTML. It's an HTML logic. So you have the body, inside of the body tag, the A scene. A scene is the environment that you're creating. And inside of the environment, you have entities, objects, like in this case, you have a box, and that is red. And the components are used like attributes, like geometry, and then you have the variables inside of the attributes, which are down, chaining down the component. You can add endless amounts of components to an entity. Like I said, inherently it has position, rotation, and scale. Scale of in the room. By the way, the scale model is metric. So 1 means 1 meter. So if you position something 1 meter in front of you, it would be -1 because you're positioned at 0. So I want to push something 1 meter in front of me, I make z -1 or -2 because 1 meter is not very far, it's 3 feet. So, and A-frame gives us a whole library of primitives, which are concise versions of entities. So I don't have to always write entity geometry box. I can just say a box, and then give the box width, height, length, and so on. And so that's just more a concise and easily readable way how to compose set objects in a stage. And on top of that, they have Mixins. And Mixins, for anyone that used to templating, is that you can create some kind of a template for the box, in that case, and give it an ID. That's ID box. And then you can add this Mixin to entities in the stage, and you can add 10 entities with Mixin box, and you have 10 boxes. You don't have to repeat the code. That's the idea of like keeping your code readable and clean. Here, really quick JavaScript escape to creating a component. All those slides are on my GitHub. You can see them there, so you don't really need to take photos. But here in this case, it's a register component foo, and I would add foo then later as an attribute in my entity next to scale, rotation, foo. And then I would give it a scheme and initialize some functionality to it. So controlling a VR environment on a mobile phone, I don't know, most of you probably know what gaze control is. I just put it out there so we are speaking the same. Gaze control is basically have a trigger in front of you at any time, and if you look at something and stare at it, either you can trigger it over timer, which would be like a fusing, or you can trigger click. Google Cardboard has touch, and Gear VR has a click on the device or the remote. So you stare at it and click it. That's and I'm now showing you a gaze-based cursor interaction. That's a component I quickly built. In this, I register clickable. Clickable is the component I want to turn objects clickable. I'm defining here. As soon as I enter with my gaze control into the object, I want it to turn red. If I leave, I turn white. And if I click, I want to change the material to a different texture. And down here you have the sphere, which has the attribute clickable, and therefore inherits all this component information. And then on the stage, in the scene, I define the camera, which is me. Inside of the camera is a cursor, and that cursor is that target. All those elements are components that are already predefined in A-frame. I don't have to create everything from scratch. So just by using those tags, I already set up the basics of it. You can recreate it from scratch too, and there's a lot of documentation about it. But I would suggest that you guys dig through the libraries to the component registry and the libraries on GitHub about what's been done in A-frame, because there's a big community and they're really excited to create functional things. This is like the best of component registry, and actually one of them, one of the components is one of the hackathon winners from our hackathon that has a what's his name again? Leonardo, yes. He made a voice control navigator. That means you look at something and you say go, and then you can actually go there. So he's tapping into the microphone off the phone hardware and uses a voice recognition API, which is a JavaScript API, and integrated it into A-Frame. And now it's available for anyone that wants to use it. Great stuff. Here's the document, the docs. Also linked on the GitHub, I just want to point it out, there's tons of stuff here and also examples of what's been done and really good tutorials. And one of the biggest assets to A-Frame is that everything has some an inspector, is empowered by an inspector. That means every time you press Control-Option-I on the Mac, I think it's similar to the PC, but not gonna, anyway, you'll figure it out. And that shows you the scene in a three-dimensional setup, and you can manipulate values and position objects in a space, just like you would do in a 3D program. So it's very, very interesting to see where objects are, manipulating them, see the values change. It's a very different approach to coding because it's really hands-on, you know? Now I just want to share a little video. I think you all have seen videos on YouTube about people using VR, but I just had to. Someone's VR roller coaster, right?
Be nice.
Yeah, it's very funny. The thing is, you cannot underestimate how much your VR experience has an impact on the actual user. No one reacts like this when they're looking at a website, unless they're looking at this like this close, and that's almost being immersed. So if you create responsibly and understand what the person is actually doing at where he could be when he is experiencing your experience, you know. So here's some resources, also linking them on GitHub, just wanting to run down to it. The component registry link, Mozilla VR, basically the website for WebVR and everything around it. There's the Slack channel from A-Frame, which is very active. I would suggest you guys join. There's about 3,000 plus people in there. It's not many, but very active. And yeah, and the link UX for VR is, in general, a compilation of wonderful user experience write-ups and videos about user experience in VR. And a little article I wrote, VR Gets Real with WebVR, on Medium that you can check out, where I can see in the try to magically see in the future. That's my contact down there. You guys are welcome to contact me anytime if you have questions about your projects and anything. So now let's get to code. What we're actually going to build today is 3 experiences. This is my GitHub repo for everyone. That you should note that one, because that's actually all the content. We actually can post it on the Hackathon website too. Then you can have all the demo files and the presentation too. When you use, when we create an VR experience.
I'll put that on the meetup. So on meetup.com, there's the Stanford Developers Meetup, and specifically there's one for the VR Hackathon. So I'll post that up there.
So when we create VR experiences in A-Frame, we have to use some local host setup because of loading images inside of the VR experience. It has to go through a secure channel, otherwise it gets blocked. So if you can, when you want to build, and there's a whole article about this on A-Frame too, so I'm just going to touch the very basics. You need to create a local development environment in order to develop for VR, for A-Frame. For this tutorial, I'm going to use JSPin, which you can use too if you want to develop with this online tool. Yeah, so I'm going to start with the pink boxes. Let me see. Okay. Where's my cursor? Okay. Good. Do you have any questions so far? Yes. You can create a WebGL, you can build an entire VR experience with WebGL. If you want to live long life, don't do it, because it's going to be more painful than 3JS. People have done it, and you can do impressive stuff with it. But I think 3JS does a really good job in making like tapping into all those different kind of variables and environments to understand it. So yes, you could create an entire thing with WebGL. You don't have to. It's JavaScript, right? So does it answer your question? Okay. Any other questions? Okay, okay. So any kind of A-Frame environment has to load the A-Frame library, and we're loading 5.0, which is the latest version right now. A lot of things that were working in 4 don't work anymore, but that's how it is when things grow. Now I am going to create the scene, which is the base. So this is my scene, and inside of my scene, I'm going to create a box. Let me just see here. An entity. And you can code along if you want to. By the way, if you look, can you read this up there? You can actually see, if you type this one into your phones, in your mobile phones, you can actually see it on your browsers as I'm going along. And you can have this VR environment basically grow inside of your phone because it's live updating. So it might be fun for you guys to figure this out. If you build your own things, go on JSPin, and then you get another like personalized link there, and then you can build it out as you go, which is a nice tool. Okay, so a entity. What's going on with my keyboard? Okay. Bigger? Yeah, I'm okay. I'm going to have you please move forward. This is what? Yeah. Sorry. Let me see. Sorry. Here we go.
Guys, honestly, though, this is a nice size group. We can scoot up if you want.
Yeah. Please feel free. Don't be shy. I don't bite. Okay, so we're defining the component geometry. And that one is a primitive box. And that box has a width of 0.5, height depth. We don't see the box yet because we're actually standing inside of it. We're going to see it once I move it. I'm moving that box now. And these are 3 values. You have x, y, and z. So x is 0, which is left to right. Then you have 2 meters off the ground. And then you have 2 meters in front of me. There's my box. It's blue right now on default. I'm going to rotate it just to make it look nicer. Um, 30, 30. So that means x, y, z rotation, 30 degrees on the y and the z axis. Now I'm going to give it a material. And then material means color. In this case, I'm going to just make it white real quick because I'm going to add a texture to it. And another thing that material does, it gives you refraction and reflection. For anyone that does 3D modeling, that's something that means how the light reacts on that object. And you can play around with those variables. That's always a fun thing to do. I'm just going to put in variables that I found to be working for my example, but maybe you have something that looks much more dull and not metallic. Okay, so in this case, okay, now I'm going to add as an image as a texture since I have. I have right now. It's gray because the room light is dark, so it's actually a white box, but not with much light. That's why it's dark. I'm going to add texture. Okay, in this case, I have to quickly copy my link because I'm coding on the web. That's not gradient, I want texture. Let me see what's going on. Texture. Okay. It's too dark to see anything right now. One second. I'm going to add lights to the scene. That's also a component that you can add. It's called a light. We have different types of lights. We have ambient lights, which is the general ambient of the room. And then you have directional light and spotlight, and there's a whole slur in the documentation I would recommend that you look at. For this example, I'm using 2 different lights. I'm using the ambient light. What am I doing wrong? And another light. Yes. You're right. Absolutely right. Thank you so much. I was going crazy. Yeah, it's forgiving to a certain degree. Well, the end tags are usually more forgiving than the beginning, but yeah, you're right. It should be compiling correctly. Directional type, and then we have color. If you see any other typos, I would be happy. But we'll see. Color, and then. That's down here. I'm actually adding attributes right now to this A-light element, and down there is the closing bracket. Or what were you talking about? Oh, it's down here. So this is all. These are all components. We'll see the slide in a bit. I just have to direct it to this thing position. And now I'm going to give it -1. So now we have a typo somewhere. Clearly. You know, when everything fails, so just copy and paste. No, I think I just have a typo, and I'm just going to copy and paste for my other. It's basically the same, but I don't want to bug fix for 10 hours. Okay, this works, and then let's see here. Where's my mouse here? There's something. Why it's not showing up? What's going on? Oh, okay. The JPEG, that's why. I thought it was a PNG. And now I have to. Come on. Here we go. There's our little watercolor box. Now we're going to give it also a sky. Sky is basically just a sphere around the entire scene, which is very big. That's how we describe 360 imagery around your scene. And here again, I'm going to copy this. It's a gradient PNG. So now, so we have one box in the room and a gradient background, which is nice and pink. It's all, and that texture is this texture down here. I can now, in order to make it more interesting, animate the box. And I'm just going to quickly copy and paste in order to save some time. I don't want the animation inside of the entity element. I'm adding animation, and all of a sudden I rotate the box. Now you see the reflection of the box, the metalness. So just to walk you through the animation real quick, it has the attribute, it attacks the attribute rotation from XYZ rotation 20 degrees to 360 degrees all the way around, goes back and forth, alternate, and takes 4,000 milliseconds, 4 seconds. Is forever, and we have a nice little ease, so it slows down in the end. And there's a set of easings that you can change to linear if you don't want any kind of slowing, just a linear move. So this is the first step of that. So now I can actually navigate inside of this environment with my cursors, and I can walk around the box, and I see it's like suspended 2 meters across. I am, by default, 1.6 meters tall, because that's the default. But you can define how high your camera sits. So if you are a 7-foot person, then you can obviously shift it up higher to 2.1 or whatever meters it is. And yeah, so if you guys want to look at this object again in your browser right now, in your phones, you could do this with this here. And then you can actually see the box in front of you. Good. Now, this is the most simplest way to create that object. I'm going to now, if you guys have any questions to this, I'm going to enhance on that. Yeah. So it's jspin.com, review without E, RIPUYA. And that's randomly created. Okay. No, you can watch it on your browser. It's just to get the VR experience, you would want to look at it on a mobile phone. Otherwise, you will see the desktop version of it on your computer. No. Okay. Okay, so HTTP. Okay, let me see if I can actually zoom in. Oops. Better? Okay, we have a few more tutorials to go through. I'd like to move on. We can look at this link again once we have this experience a little bit performance enhanced. And I want to show you some things you can do in order to make this better. So one thing we learned about organizing code is that you want to actually create, do you want to detach assets like images or like create templates like Mixins before you actually use them in the scene. Right now we have a very unpractical way how to describe the element because everything is inside of the element. What if I want to duplicate this box and make it several boxes? So I'm creating a assets tag which shows which will contain my assets of the scene. I can add in this image source and ID. And the ID would be texture. I would have, let's say, 3 different kind of textures. And I'm going to add those in a second. texture A, B, C. And again, the devilish long link here. Goes here. And this is going to be JPEG. Oh God, I can't spell. By the way, if you guys go on the link on your computer, you can actually see me live type the code too, so you don't have to you can just copy and paste stuff. That JSPin link. Yeah, I can share the editor, and now you can see what I'm doing. That might be more helpful. Sorry, I forgot. Okay, now let's create a Mixin. Now I have 3 images loaded on the top of the website container, so I can actually add maybe JavaScript calls to see, once all images are loaded, show me the scene. So in this case, you can optimize for performance. Now I'm going to create a Mixin. Like I said, I showed you in my presentation, which is the Mixin with the ID box, geometry box, and all these components and their variables. And now let's go into this box, the entity here. And all I need for this, all I need here is now just to reference the Mixin and give it position and rotation. I can look at your thing in a bit. Let me just quickly. Okay, let's do this. So now what we have here is nothing changed on the box, obviously. But what happened is I added the Mixin box, which is the Mixin I created up here. All the variables are hosted now on the top in this kind of template. And now I'm referencing the template in this component, and I'm adding the texture A to this entity. And now we can duplicate. We can add another box with another texture and another component, another position inside of the space. Here we go. There's another one back there. All I did is change the texture to texture B, which I reference up here. Yeah, I just copy and pasted and exchanged A and the positional rotation, and also the angle of rotation and the duration, just to give it a little bit of a different flavor. And just because we're doing it right now, I could add multiple ones. Now, this is how you quickly reproduce different objects and create the definition of an object in a template and then repurpose it, but you can still adjust things like height and within the entity here. So let's say if I wanted to change the material to something else, or to the geometry to be taller, I would add geometry height 2. Let's do this real quick. So like this, I'm overriding the Mixin. Okay, spelling. See that? So it's pretty quick. And for everyone that wants to get this approach much more into like the JavaScript description of things. Now this is a very HTML way to approach things, just to show to everyone that has more JavaScript experience a very quick look at how you would describe these elements in JavaScript and place them into the stage. You would do it, first of all, I would take all these entities out because I'm going to add them with JavaScript. And then down here, I would adding the script, and I'm just copy pasting it because I'm typing too slow. But I'm going to walk through it with you guys. Yeah. And now, here we go. I have 3 boxes. I'm looking at the scene element, and then I'm creating the element entity box A, B, and C, giving the attributes mixin box and the various components and their variables, and then I'm going to add those to the scene, and then I'm adding animation to it with like timer based on the rendering of the frame. It's rotating like that. Good. This is the first part. Any questions, except you with the issues? Do you have still issues? So it's good now. It's not working? Which browser are you using? Weird. Yeah, we'll look into this in a bit. So now I'm going to show you the second tutorial. I'm running a little over time, Hugh. Is that okay, right? We're good?
Great shape.
Okay,
Yeah,
cool.
keep going. So guys, our Unity will just follow 5 minutes after this. So we'll keep going and ask questions and get good stuff done. Yeah.
Oh, good. That works with me. Okay, so so the next example, we're going to create a space scene, and I'm going to use a lot what I already showed here, just to give you a little idea of the potential. We're going to create again assets, 2 assets, 2 images I need. One is I want the space and I want the earth, and I'm just going to, sorry with this link, but this is the only way I can really get my stuff from my repo. Here we go. So we have this, and then we have, okay, earth and space. I don't need this anymore, and I don't need this anymore. Okay. Okay. Now, the sky down here will get as source the reference sky, which I'm showing up there. Right? There's no, it's space, not sky. Sorry, space. Space. Yeah, the ID. I'm referencing. Ooh, stars. Okay, good. So all of a sudden we are in space. Now I'm going to add a sphere, which is supposed to be Earth, and also I'm adding rotation to the Earth. But my wife said if the Earth doesn't turn, it doesn't look real, okay? So obviously it's 7 meters radius, which is not Earth, but it makes the impression that we are in space in order to, you know, so that's Earth and space, and we are there, and we can actually navigate through it. So now let's put a space shuttle there. Now, the nice thing about A-Frame is you can actually load external objects, 3D objects, into the VR experience. So you don't have to describe everything with primitives, boxes, squares, spheres. You can add content. And there's websites like Clara.io and open source websites where you can download objects, 3D objects, and use them. So you can very quickly compose a VR environment. Let's say I want to create a living room, and I can just load in the library from Herman Miller chairs, and I can decorate my room fancy. So, and that would be 3D objects. That would be to scale, and that would be interesting too. So, that is a primitive. This is just a sphere, and I used an image. Well, it has a PNG file, which is a equirectangular image, and you can find equirectangular images now everywhere, since there's like 360 cameras all over the place now, and you go on Flickr and you can find that. You can even get videos, and YouTube has now also the support for VR videos, 360 videos, and you might have seen some of those already, where you can just basically like move around, like walk around in the video, like look around in the video. It's a 360 experience. So this is just a texture on a ball that's turning, but that does the job. And now we're going to add a space shuttle. And I just have to... Also, I have that space shuttle in my assets, but I'm referencing it here like this. So we have an A object tag. We define the source here, and the material, which is the map, like the color and the image. And there it is. All of a sudden, we have a 3D object in space. And now I'm an astronaut, and I'm going to go home, and I'm going to go in there. So you can... Yeah. The best format I would suggest is actually GLTF, which is the JPEG of 3D formats. It directly uses WebGL as an accelerator, and it doesn't use much performance. It is a 3JS JSON model for 3D, which works well, but the Kronos group, which is handling WebGL and all this, there's the non-profit, they actually defined the format GLTF for that kind of purpose, so I would suggest even. But in my case, I just use an OBG file. So, and I don't really know. There's a lot support, Collada models. It's all in documentation. I would suggest you look into it. And also, there's best practices of reducing polygons. You just want to keep it very simple. And the WebVR experience really lives through the textures and the actual experience. So if you think about making something really beautiful, then you really have to pay attention to the imagery and the textures. There's ways to give shaders, get shaders into this, and there's components. We have like particle systems, like snow, and so there's a lot of stuff already out there. It's never going to be the level of a headset that is powered by a powerful computer, but it doesn't need to be, as we saw with games like Minecraft. The experience is more important than the visual aspect to it. And I feel like I'm trying to build beautiful things with A-Frame because why not? We don't need to have red boxes, you know. I just want to make something look good. So just to show. Obviously, we can get a better resolution of the map too, but for this example, just really quick. Okay, this is the second example in my demo example. Do you have any questions about that else? No one? We can jump on the third one. Ready? The next example I'm going to talk to you guys about is using gaze control and physics model, physics engine. For that, now we're using a different component. We need to load in the physics component, and you can find that also on the registry. In order to make things behave physically, you have to give the objects, obviously, the attribute. In this case, the whole scene actually needs the attribute because you want to make things physical in the scene. And here you can define either you're on Earth or you're in space, and so you can change gravity and stuff like that. It's pretty cool. Now here I have 4 assets. Just quickly open here. I have a sky, I have grass, I have a basketball and a football. A football in the European football way, not a soccer ball. And I don't need these anymore. I'm just going to... Yeah, my space shuttle still exists because I'm loading it within the scene, but I'm going to get rid of it in a second. Okay. Do we need light? Yes. Okay. Directional light. Gets the same color. And I don't need this anymore. And sky. So now we have a, okay, we're going to remove the sphere. That was our world. So now we have a normal 360 photo, and you can see it's pretty much just that. This is my 360 shot. If you have a 360 camera, and they're like $100 nowadays, you can take a photo and you can load it in just like that. So you want to show something. It's pretty simple. Okay, now we have the sky, and we want... I'm now adding a camera and a cursor, which is me, camera, and cursor is this little black circle. That instantly gives me the possibility to target things, because now I have a cursor to point at something. And I'm adding a plane, which is my ground. Now I have a ground with a grass texture on it. Grass texture, and here I'm referencing it, and I'm repeating it 100 by 100 times because the plane itself is 300 meters by 300 meters, so it's a big plane. And then I have, I'm adding a little trick here because since I'm going to drop something, I'm adding a small little cone just to redirect it so it doesn't bounce on the same spot. Just adding a small little cone, tiny. Yeah, you don't really see it. I don't want you to see it. If I drop the ball from the sky, it should bounce to either side. So I just drop it on a pin. So that's my little trick. Here is my basketball. And what's happening now is I'm actually dropping a ball. What happens? I have a sphere that has the source basketball, which is the graphic I'm having in the assets up there. The radius, it's a huge basketball, it's 0.5 meter. And it's like 1 meter across, it's like this. It doesn't matter for my example. Base color is white. The position of it, I'm positioning it 15 meters above me, it's 45 feet, and 4 meters in front of me. And I'm dropping it. And I'm dropping it because I'm telling it it's a dynamic object, a dynamic body. That attribute is an attribute that inherits from my physics component. The physics component looks for 2 different kinds of attributes. One is dynamic and one is static. Now, we have a static plane because I don't want the ground to move. I want only the ball to move. On top of that, I'm adding to the sphere a clickable component. I haven't written this component yet. I'm going to just quickly copy it in, but that's an additional component that I add to this entity in order to make it clickable. Okay, so I'm going to quickly copy the code for that. In the header. And then I can click it. So now I'm defining the component clickable. And it's hard to see, but once you, with the cursor, go over the ball, it turns blue-ish. Yeah? So I can follow the ball. I can target it, and it turns blue. But now when I click it, it turns into a soccer ball, because I'm exchanging the texture. That's my little game. Yeah, and then at some point it stops rolling. But that's the idea. So I'm creating a physical object, I'm interacting with that object, and I'm changing something when I interact with it. That's the third part of my tutorial here. Do you guys have any questions? Yeah, so you can use 3D video as texture, just like an image, reference it. Problem is performance, really just performance. There's examples of 3D video on the website. I'm done with the tutorials, and I can walk you through the A-Frame website if you want to. Yeah, because it's nice to see what they have as examples there. It's A-Frame.io, and here you can see. So these are animated. This is also already. It's also built with A-Frame. Here's the 360 video, and that's basically. Now I can look around, but you see the performance is the issue, really. So if you want to load a video beforehand and make sure the performance is not like staggering. It's always worse on mobile, because if you're streaming it, you're depending on a 3G or 4G network. I always would recommend to cache it, load it down, download it first, and then like do the loader bar and then execute. That would be easier. Yes. Yeah. So you can change 2D into 3D. You can create a plane inside of the VR experience that displays the 2D video. You could recreate the cinema experience, movie theater experience like that. But if you want to be immersed in something, you have to have a camera that captures 180-degree fisheye on both sides. So capturing 360 imagery or video is a whole different game. There's cameras that do that nowadays. There's a Gear, what is it called? Gear VR has a camera. What's it called? Gear 360 is a camera that you put on a very thin pole, and then it captures 360 around you. There's LG has a 360 camera. They're coming out. Even I think in China they have now a phone that directly does 360 photos directly from the phone, which is a funny gimmick. But yeah, so the idea is that when you take photos or video, if you capture 360, there's no way to escape the shot unless you remote control it and hide behind somewhere. That's some aspects, and I talked to a few people that create VR video, like 360 video experiences. They have to actually rethink the way they capture video, because not only do you have the problem that you are in the shot, you also have the problem that you have to direct the user's attention to where do you want the scene to be happening. And you can't control someone that just looks in the other direction. If you have action going on the left and you look right, you miss it. So there's a lot of techniques like guiding the user back to the focal point of the scenery. A lot of the compositional parts of creating videos and movies is directed around the frame of the image. So all these, like, how does the composition work, and all that is basically up for grabs in 360, because and there's rules not to force the viewer's eye to a position, because you do not want to make the user uncomfortable, seasick, or whatever it is. So you don't want to like force a viewer to the left, even though they're looking right. So that's a break of immersion, and it's not a very comfortable experience. So there's a lot of techniques. But like I said, the Tribeca Film Festival, and I'm not getting paid for this, but they're actually having really interesting scenes, really interesting examples of 360 video and stuff where you can see where light is the director of the attention, or sound, because you can create sound effects and that drags the attention. Yeah, so there's a lot of different things. So when you build, compose about a 360 video, if that answers your question. More or less, yeah. It's not practical. You can't, unfortunately. Yeah. Yeah. Well, I can tell you, because Hugh is in that same field, but the thing is, you can have a big video screen in VR. You can put yourself in an IMAX theater if you want to and see it big. But the idea behind that you're having a 2D video is, what else can you add to the virtual environment? Because just being in front of a video is not really, it's maybe forcing your attention to just that thing. But what else can you deliver inside of the VR experience? Can you give another set of tools, a set of feedbacks? Can you say, oh, I want to snapshot that part, or I want to grab this for later, or I want to talk about the topic that's talked about right now with this and this person. Maybe you have an environment where you have multiple people that sit in the same room watching the same video, and they could be across the world. And then you can interact within that VR environment with that training video. That's more like the idea behind it, right? And yeah, so if you create a 360 video with this immersive space, and maybe you have someone coaching you inside of the 360 video how to apply certain things in environment, and you can snap from location to location within that 360 environment. Let's say I want to sit on stage at South by Southwest. So I have a 360 video of South by Southwest and speak in front of people, or I'm speaking here at the hackathon, and with a snap of a button you have a different experience, a different environment, just because you exchange a 360 video or something like that. So that's the thinking. Yes? You mentioned something in the beginning about having one-off workloads. Is there anything special you have to do to set up a web server for public? Well, the only problem is that image references have to be on a secure server, because it's the CORS, CORS. Yes, you can. Yes, you have to do that. Yes, that's why it's like, yeah. So you can use, if you have a PC, XAMPP or Mac MAMP, or just a simple server of Python. I have links to it on my talk, and there's a lot of stuff out there. It just gives you the basics, and it's quick setup. It's just downloading one application, makes it easy for a local environment to develop on. You can build your applications on JSBin because it's a secure website, and you just have to reference textures and links on a secure server. That's how you can do it. Or you have a secure server and then work locally and pull these images from your secure server. Then you don't need a localhost setup. Okay, any other questions? Yes? Well, React works very similar to A-Frame. Actually, it's building on the same principle. The difference with React is that it's defining little modular blocks. So every entity could be a React model. You define an environment modular, just like pulling in entities and templates. I mean, for people that like React, it's very nice and powerful and scalable, but you don't have to know it in order to build this thing, you know. Basic HTML skills, that's it. And that's easy to pick up. And I feel like if you want to have an experience that other people can learn from, that don't know heavy-duty JavaScript frameworks, then you're better off building it with A-Frame, right? Because the community wants to help you, you know. You want to make it easy to cooperate. Yes? See, this is the thing. If you would build everything from scratch, you would have to, well, I like the fact that the community takes care of things expiring or becoming irrelevant. So if you use 3JS, at some point 3JS will update everything that's going on in WebGL. By A-Frame, I'm using 3JS and WebVR, and A-Frame is going to update its library based on the latest things that happen in WebVR. So it's less things to track. I feel like the community is strong enough to understand what's going on and where is it going. Yes. Well, the problem with WebVR was that everything was around the idea of device motion and device position. It was very focused around the phone model. And in order to make WebVR function on all different kind of headsets, may it be Oculus or HTC Vive, which actually works. They have browsers, and Oculus has the Carmel browser. Those browsers will use WebVR in a way that you can use the controllers and the frame rates and the resolutions to the level that the device allows you to. Right now, WebVR doesn't really focus on the idea of taking too much information in from the device itself. So it is. Yes, it's very much performance oriented. So give me higher resolution if my computer, if my headset can handle it, and the frame rate. Because frame rate and latency, all these different variables are really key to making a VR experience like pleasant and comfortable for the user. Yeah. Any other questions?
That's awesome.
Yes. Yeah, so browse this website. It has nice stuff. There's like ideas about shopping in VR, you know, like.
But also Mozilla has a blog that they're really active.
Yeah.
They're crazy.
But the nice thing, and I can show you here, is that it Control-I. Now I'm loading the inspector, and here we go. We have the A-Frame inspector, right? So you can move things around. I just have to select him. Where is he? Colada model. And then I can say, oh, I'll make you sink down, and stuff like this, you know? So you can modify objects, and it will tell you here X, Y, Z, position, rotation, scale, everything. And you have like the entities as like nested elements, very easy to see. Right? And then here, in this case, curved image. And you have all these different kind of materials and toggles, like is it transparent or not, and stuff like that. All these are variables of the component. So you get a nice little overview and can turn on and off things as you go. Okay, I think I'm good.
That's great.
Yes.
So guys,